Hi students, we will be learning how to factor quadratic trinomials in this lesson using the X method. So I'll teach you how to use that. We're going to do lots of examples. If you start to get the hang of it, pause the video, try the next example, and then press play and see if you're on the right track. But you will have to practice lots and lots and lots to get good at this, and it's a very, very important skill. So these are the steps I put together to follow in order to factor quadratic trinomials. I had you write these down also from Canvas. This is just kind of a summary of the steps. Right now they're not going to make a whole lot of sense until we start doing some examples, but once we do, you'll be able to refer back to this to kind of keep you on track each time you do it. You'll get good enough where you don't have to look at the steps anymore. But the very first thing we're going to do is we're going to take a look at our quadratic trinomial, and if we can, we're going to factor out a GCF, which we learned how to do last week. If there's no GCF, but A is -1, meaning the coefficient of my x squared term is -1, I do want to factor that out as well. I don't want the A to be negative. So we'll look at that in a minute. Next thing, and I know you guys can do this, you're going to identify the A, the B, and the C from your quadratic trinomial. I know you guys did this when we practiced quadratic formula, so I know you can do that. The next thing is to set up our X. You're going to draw a big X. At the top, you're going to put A times C, whatever that product is, and then the bottom you're going to put B. The next thing you do, and this is kind of a guessing and checking, step 4, this might take some of you a while. You're going to try to find two numbers that are going to multiply to make the product of A times C, and they also have to add to make B. So I'll show you how to get that in a minute, but that's the hardest part. It's not hard, it's just a little tedious. After you find those two numbers, you're going to divide them both by A. Now if A is 1, you can skip this step. When you divide by A, you're going to reduce. When you reduce, you'll either get a whole number or integer or a fraction. Whatever those are, in the next step, step 6, you're going to put them here and here in these two binomials. Step 7, if either of those numbers were a fraction, you're going to take the denominator, the bottom part of the fraction, and you're going to move it in front of X. So you would put it here or here from step 6, and I'll show you how to do that. The very last thing you're going to do is you're going to take a look at both binomials and you're going to check to see if that's your answer by doing the opposite of factoring, which is simplifying. And we can multiply two binomials or simplify them using either double distribution or the box method, which you guys learned a while back. So these are the basic steps. Here's our first example. We're going to factor this quadratic trinomial. I know it's quadratic because I see that exponent of 2, that gives it away. I know it's a trinomial because I have 3 terms. So here's how we do it. First thing, see if we can pull out a GCF. I'm going to look at each term and see if they have any factors in common. I don't see any, so I'm going to skip that. Step 2, identify the A, B, and the C. The A is in front of your x squared term. So in this case, it would be 1. There's my A. My B is the number in front of x. In this case, it would be -3. And then the C is the constant at the end, so it's -18. Step 3, you're going to set up your X. Okay. In the top, we want to put A times C. A times C in the top. I'm just going to write it here. And then in the bottom, we're going to put B. Okay. So I'm going to go ahead and we're going to do that. A times C would be 1 times -18, which would be -18. My B is -3. So you're going to get in the habit of doing this. Step 4, this is the step that's going to take the most thought. It's not hard, but it may take some of you a while. You may want to have a calculator handy just to check your work. You're trying to think of two numbers, and we're going to put them here and here, that when I multiply, I get negative 18, but when I add them, I get negative 3. So let's think about some numbers that multiply, first of all, to make negative 18. In order to equal a negative, I've got to have one positive and one negative, right? So maybe negative 2 times 9. That equals negative 18, but if I add those, I get 7, which is not negative 3. So that's not going to work out. So I got to think of another combination. I know that 6 times 3 is negative 18. If I made maybe the 6 negative and the 3 positive, those two numbers would multiply to make negative 18. If I was to add those two numbers, I would get negative 3. So you can use your calculator to check the multiplying and the adding if that's not a strength of yours. But these are the two numbers that are going to work. So step 4 is done. Step 5, I'm going to divide both of these numbers by a. Well, my a is 1. Dividing by 1 isn't going to change the numbers at all, so I don't have to do that step if my a is 1. So I'm going to skip that step. Step 6, we're going to set up the binomials. So my answer is going to look like a binomial, two binomials. We're going to have x at the beginning of each binomial. And then after that, we're going to put the two numbers that we figured out. That's this negative 6 and 3. It doesn't matter which one I put where. It totally doesn't matter. Put the sign of the number in front. So I'd have x minus 6 and x plus 3. Like I said, if I switch these and put the x plus 3 before the x minus 6, that's totally fine. Step 7 says if there's a fraction, after we reduce from dividing, then move the denominator in front of x. I don't have any fractions, so I can skip this step. Step 8 is to check by double distributing or the box method. So let's go ahead and try that. So, to check, we're going to rewrite it. Remember, simplifying is the opposite of factoring. What I've done just now is I factored. This is what I got. I want to simplify it, the opposite of that, or double distribute. And you can use the box method here, or you can just use the FOIL, the double distributing, to make sure that we get what we started with up here. That's our goal. So let's go ahead and practice this skill. X times x is x squared. Remember, we add the exponents of the 1. Now we're going to do x times 3. That's 3x. Now we're going to move to the negative 6 and distribute that to the second parentheses. Negative 6 times x is negative 6x. And negative 6 times 3 is negative 18. Remember, when you do this, you'll have 4 terms. Usually the 2 in the middle will combine. 3x and negative 6x combine to make negative 3x. I still have the minus 18 at the end. I've got the x squared at the beginning. This is what I started with up here. So that means my answer was correct. This is what it looks like whenever you factor a quadratic trinomial. You're going to have two binomials. And it's going to be really strange at first, but I promise you'll get really good at this. Next example. Let's follow the steps again. And each example is going to be a little bit different than the last, so you really want to go through every example. Step 1, factor out a GCF if possible. So I'm looking at my terms, 4x squared, 48x plus 128, and I can see, I believe that they all can be divided by 4. So I believe that I can bring out a 4 to the front, and I'm going to put what's left in parentheses. 4 times x squared would give me that 4x squared. Okay? 4 times 12x would give me that 48x. and 4 times 32, I believe, would give me that 128. So I believe I'm good. Okay, so I factored out a 4. 4 is the GCF. I'm going to now look at the remaining or the resultant quadratic trinomial, and I'm going to just factor that part. When I get my answer, I'm still going to have the 4 in front, and then I'll have the binomials after the 4. Don't forget about this guy if you pull out a GCF at the beginning. It's very common to forget about that guy. All right, step 2 is identify the A, B, and C. So I'm going to switch gears here a little bit. The A is in front of my x squared term. So in this case, my A is 1. My B is in front of my x term, positive 12. My C is the constant at the end, 32. Step 3 is go ahead and set up your x. Remember, in the top we want A times C, and in the bottom we want B. So A times C is going to be 1 times 32, which is positive 32. Signs are super important when you're factoring, so make sure that you're putting the right signs down. B is 12. Okay, step 4, the trickier part. We're looking for two numbers that multiply to make 32, but add to make 12. Multiply to 32, add to make 12. The first numbers that come to mind for 32 are always 4 times 8. Well, 4 times 8 does equal 32, and 4 plus 8 does equal 12. So those are the two numbers that I want. Step 5, divide both numbers by A. Our A is 1, so I don't have to do this step. 6, set up our binomial. So we're going to come over here. Now, I don't want you to forget about that 4 in front. Now we're going to set up our binomials. We're going to put x and x, and then we're going to put the two numbers that we have decided upon. They're both positive, so I'm going to put plus 4 and plus 8. So those are our two binomials. 7, if there's a fraction, move the denominator in front of x. I haven't had to do that yet. So number 8, we're going to check by double distributing. Let's go ahead and check. So we've got, don't forget about the 4 in front. We've got x plus 4 times x plus 8. I'm going to double distribute with the binomials, and then whatever I get at the end, then I will multiply that by the 4. So we kind of have a couple of steps here. Let's go ahead and do that. So we still have the 4 in the front. X times x is x squared. X times 8 is 8x. 4 times x is 4x. 4 times 8 is 32. So remember, we can usually add those two middle terms together, which is going to give me 4 times x squared. 8x plus 4x is 12x, and then plus 32. I can already see that this part matches this part. So now I just need to distribute that 4 to make sure that I get the original expression. 4 times x squared is 4x squared. 4 times 12x is 48x. And 4 times 32 is 128. This does match this, so that means this is the completely factored answer. All right, here's the next example. Step 1, see if you can factor out a GCF. If I look at all these terms, 18f squared plus 30f plus 8, I think they can all be divided by 2. So I'm going to pull out a 2 in front. 2 times 9f squared makes 18f squared. 2 times 15f makes 30f. And 2 times 2 times, 2 times 4 is going to give me the 8. Make sure I did that right. Awesome. Okay, step 2, you're going to identify your A, your B, and your C. So our A is the number in front of 9. Sorry, in front of f squared. That's 9. The B is in front of my f, which is 15. And the C is the constant at the end, which is 4. All right, so we've identified A, B, and C. Step 3, we're going to set up our x. On the top, we're going to put A times C. On the bottom, we're going to put B. A times C, or 9 times 4, is 36. Our B is 15. Step 4. What two numbers multiply to make 36 and add to make 15? So let me just first think of numbers that multiply to make 36. 6 times 6 makes 36, but 6 plus 6 is not 15. Okay? 12 times 3 makes 36, and 12 plus 3 makes 15. So these are the ones I want to use. Step 5, divide both numbers by A. Finally, we have an A that's not 1. So what we're going to do is we're going to divide the 12 and the 3 by that A, which is 9. So what we have here, I want you to divide those in your calculator. It will either give you an integer or a fraction. Okay, don't convert it, no decimals when we're factoring. So 3 divided by 9 is 1/3. That's what it simplifies to. And 12 divided by 9 simplifies to 4/3. Okay, so this is the first time we have fractions, so I'm going to show you what's going to happen in just a minute. Step 6, we're going to set up our binomials. So I'm going to come back over here. Don't forget the 2 in front. We're going to put our x followed by our two numbers we just found, which are now fractions. So I've got x plus 4/3 and x plus 1/3, and they're both positive. Step 7. So this is new. If there's a fraction, we have two fractions. We are going to take the denominator from each fraction and we're going to move them to the front. So I'm going to take this 3 and I'm going to move it in front of the x. I'm going to take this 3 and I'm also going to move it in front of the x. So what we have now is 2 times 3x plus 4 times 3x plus 1. So this is what I think my answer is. Of course, next step, step 8, we need to go ahead and check this. So to check it, let me come over here and run out of room. I'm going to rewrite it. 2 parentheses 3x plus 4 times 3x plus 1, and I highly suggest checking it each time. I know it's an extra step and it does take a little bit of time, but until you get really good at this. When you get really good at this, you'll be able to kind of like mentally check it. So let's go ahead and double distribute. Here we go. 3x times 3x is 9x squared. Make sure you're adding those 1 exponents. 3x times 1 is 3x. 4 times 3x is 12x. And 4 times 1 is 4. Now we're going to combine those two middle terms. 3x plus 12x is 15x. So we have 2 times 9x squared plus 15x plus 4. I can see, I just noticed that I'm using x when I should be using f. Now this is a common mistake. not a big deal, but you just want to switch out your variables, make sure they match. So I'm going to have to make sure they match. But if I look at the coefficients, it does match that up there. So let's go ahead and distribute the 2, last step, and see if we get what we started with. And then we'll switch those exponents back to f. 2 times 9x squared is 18x squared. And I'm going to go ahead and put f squared. 2 times 15x is 30x, but I'm going to put 30f. And 2 times 4 is 8. This is exactly what we started with here. So this is the correct answer, only though if I change these variables out for f, of course. Putting the wrong variable is a common mistake. When you take your quiz, there are going to be different variables. If you enter it with x and not the correct variable, if it's not x, then it will be counted wrong. So pay close attention there. I'm glad that I made that mistake in front of you so you can see how easy that is to make. All right, next example. First step, pull out the GCF, greatest common factor of 7x squared, 26x, and minus 8. I can't think of a factor they all have in common, so I don't think we have to do step 1 here. Step 2, identify A, B, and C. A is the coefficient of your x squared term, that's 7. B is the coefficient of your x term, that's 26. C is the constant at the end, that's negative 8. Step 3, set up your x. We're going to put A times C in the top and B in the bottom. A times C is 7 times negative 8, which is negative 56. And then my B is 26. So these are a little bit bigger numbers. For step 4, remember we're finding two numbers that multiply to make negative 56 and add to make 26. So let's think about this. Numbers that multiply to make negative 56. We've got 7 and negative 8, which we just used. However, those don't add up to make 26, so we'll get rid of those two guys. 56. If I was to divide 56 by 2, I would multiply it by 28. Now keep in mind, in order for those to multiply to make a negative, one of them has to be negative. So let's say that my 2 was negative. If I was to add negative 2 with positive 28, I would get positive 26. So these are the two numbers that I'm going to use. Step 5, divide both numbers by A. If A is not 1, well, our A is 7, so we are going to divide both of these by 7, and then we're going to simplify them or reduce them. Negative 2 over 7 is completely simplified, and remember you can use your calculator to do this. 28 divided by 7 equals 4. So this one actually makes an integer. So those are our two numbers. Step 6, set up your binomials, excuse me. So in one we have negative 2 over 7, so we'll have x minus 2 over 7. In the other one we have positive 4, so x plus 4. Remember, if you were to switch this set of parentheses with this set of parentheses, that's not a big deal at all. Okay. Step 7, if there's a fraction, and yes, we do have a fraction, we are going to take the denominator of that fraction, which is 7, and we're going to move it in front of the x. And then the denominator's gone. So our corrected answer is 7x minus 2 for one binomial, and x plus 4 for the other. In order to determine if this is correct, step 8, we always need to check it. So I'm just going to rewrite it. And I hope that you're writing these down with me so you can have some good notes to look back at. Let's go ahead and double distribute here. Seven x times x is 7x squared. 7x times 4 is positive 28x. negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. We're going to combine those two middle terms. 28x minus 2x equals positive 26x. So I've got 7x squared plus 26x minus 8. This does match what we started with. So that means that our binomials were correct. This is the factored version of that trinomial. As you do this a lot, and especially in the checking part, you're going to notice some things. Notice right here where these two terms combine to make 26x, the 28 and the negative 2, those were the two numbers right here that we came up with. So you are going to see some patterns and some connections. All right, here's our next example. Step 1, factor out the GCF. I don't see a GCF other than 1 for 3x squared minus 17x and plus 20. So we're done with that part. Step 2, identify A, B, and C. A is 3. B is negative 17. And C is positive 20. So there's our A, B, and C. Step 3, we're going to set up our x. We're going to put A times C in the top, B in the bottom. A times C is 3 times 20, which is 60. And our B is negative 17. Step 4, we're trying to find two numbers that multiply to make 60 and that add to make negative 17. So let's think of some numbers that multiply to make 60. I know that 3 times 20, which is what we just did, multiply to make 60, but those don't add to make negative 17. Two positive numbers will never add to make a negative number. So what we need to do is we need to think of the two factors we come up with that multiply to make positive 60 as both being negative. That's the only way we're going to have two negative numbers add up to a negative number. Okay. That doesn't work though. So let's try some new numbers. Keeping in mind they both are going to have to be negative. Some other numbers that multiply to make 60 are 15 and 4. However, negative 15 plus negative 4 does not add up to make negative 17. So we need to try again. Okay, still running through all the combinations that multiply to make 60. We've got negative 6 and negative 10. However, that adds to make negative 16, not negative 17. I think I know what it is. How about negative 12 times negative 5? Those multiply to make positive 60, and they add to make negative 17, so those are my two numbers. Notice this one took a little bit longer, and sometimes they will. Step 5, divide both numbers by A. Our A is 3, so we're going to divide these both by 3 and reduce. Put that in your calculator. Negative 12 divided by 3 reduces to negative 4. Negative 5 divided by 3 stays negative 5 over 3. There are two numbers. Step 6, we're going to set up our binomials. So in one binomial, we've got x minus 4. In the other binomial, we have x minus 5/3. Now, step 7 says if one of these is a fraction, or if either are a fraction, we've got to move the denominator in front of the x. So on the negative 5/3, I'm going to take that denominator of 3, move it in front of the x, and it's gone. Let's go ahead and rewrite this. I still have the x minus 4 as one factor. My other factor is 3x minus 5. So this is what I think my answer is, factored. Last step is to check. Let's go ahead and check. So let's double distribute. X times 3x is 3x squared. X times negative 5 is negative 5x. Negative 4 times 3x is negative 12x. And negative 4 times negative 5 is positive 20. Combine those two middle terms, negative 5x and negative 12x, combine to make negative 17x. Bring everything else down. And this matches this up here, which means that the binomials I found were correct. All right, step 1, pull out the GCF. No GCF. Step 2, identify A, B, and C. A is 3, B is -7, C is -6. Step 3, set up your X. A times C at the top, B at the bottom. A times C is 3 times -6, which is -18. B is -7. Step 4, the thinking step. What are two numbers that multiply to make -17 but add to make -7? Let's just go through some things. Remember, to multiply to make a negative, one of the numbers has to be negative. So maybe -2 times 9. Those multiply to make -18, but those add to make a +7. So what if I was to change the -2 to a +2 and change the 9 to the negative? That still multiplies to make -18, but now it adds to make -7. So these are the two numbers I want to use. Step 5, divide both by A. A is 3, so we're going to divide both of these by 3. 2/3 is already reduced. -9/3 reduces to -3. Now I'm going to take both of my numbers, and for step 6, I'm going to put them in the binomials. So I've got x plus 2/3, and I've got x minus 3. Step 7, if I have a fraction, which I do, move the denominator in front of x. So I'm going to take that 3, move it in front of x, and now it's gone. Let's go ahead and rewrite this. 3x plus 2 times x minus 3. And last step, always check. Oops. To check, we're going to double distribute. So 3x times x is 3x squared. 3x times -3 is -9x. 2 times x is 2x. And 2 times -3 is -6. Combine those two middle terms, -9x plus 2x combines to -7x minus 6. 3x squared's in the front. And once again, look at me, I used x instead of g. No big deal, but let's switch out the x's for g's. Oops. Silly me. Very easy to do. Not the end of the world. But that does match this, which means this answer is correct, assuming we replace the x's with g's. And there we go. There's your answer. Next example, step 1. And we're almost done, guys. We've got 3 more. Factor out a GCF. I can't see a GCF other than 1 for 5, 17x, and 6x squared. So I'm going to go on to step 2. Step 2, identify A, B, and C. Now, if you notice, this is not in the form ax squared plus bx plus c. It's got all the right components, but they're in a different order. Here's my squared term, here's my bx term, here's my c. So I need to kind of rewrite this. Whoops. Not that. Okay. So I'm just going to rewrite it. I'm going to put my x squared term first, so 6x squared. My x term second, so plus 17x. And then your constant always goes at the end, plus 5. Now I can correctly identify my a, my b, and my c. So my a is 6, my B is 17, and my C is 5. Sometimes you will have to do this, so just be careful. Step 3, let's go ahead and set up our X. A times C at the top, B at the bottom. And hopefully by now you're able to kind of go through the steps a little bit faster without having to think so much. You might even be able to kind of eliminate steps or do some steps together when you get good at this. A times C is 6 times 5, which is 30 in the top, and B is 17 in the bottom. So step 4, what are two numbers that multiply to make 30 but add to make 17? The two that come to mind immediately for me are 2 and 15. Those multiply to make 30 and they add to make 17, so we're good. Step 5, divide both numbers by A. Our A is 6, so we're going to divide these both by 6. Just type these in your calculator. Your calculator will simplify them for you. 2 6 simplifies to 1/3. 15 6 simplifies to 5/2. It doesn't matter if your fraction is improper or not. You just don't want to write it as a mixed number. Step 6, write this as two binomials. So we've got x plus 1/3, and they're both positive, so they'll both be plus, and x plus 5/2. Step 7, if you have a fraction, which we have two fractions, you're going to move the denominators in front of the x. So I'll have a 3 in front of this x, and I'll have a 2 in front of this x. Let's go ahead and rewrite this. 3x plus 1 is one factor. 2x plus 5 is the other factor. Last step, always check. And we'll do that by double distributing. 3x times 2x is 6x squared. 3x times 5 is 15x. 1 times 2x is 2x. 1 times 5 is 5. Let's combine those two terms in the middle. 15x plus 2x combines to make 17x. Bring down the plus 5. Bring down the 6x squared. And this does match what I started with once I rewrote it in the correct order. So that means my two factored binomials are correct. Alright, this one, I noticed that the variable is t, so I'm going to make sure to be cognizant of including a t, not an x this time. I also noticed that I'm not in standard form, so I need to kind of rearrange it. Keep the signs with it. Notice that in front of t squared is negative. And then you'll follow it by just the variable by itself and then the constant at the end. Alright, if I'm looking at this, first thing is to pull out the GCF. I don't see a GCF, however, I do notice that my A is a negative 1 in front here. Let me write that a little clearer. Is a negative 1. If your A is negative 1, you must factor that out. A cannot be negative. So let's go ahead and pull out a negative 1. All that does is it just changes the sign of everything. So my negative t squared is now going to be positive t squared. My negative 3t will be positive 3t, and my positive 70 will be negative 70. Alright. Step 2, identify your A, your B, and your C of the resulting trinomial. So we'll worry about the negative 1 again at the end. So the A of my new trinomial is a positive 1 because I've made it that way. The B is now a positive 3, and the C is now a negative 70. Be really, really careful here. Alright, step 3, go ahead and draw your X. A times C on the top, B on the bottom. Our A times C is positive 1 times negative 70, which is negative 70. our b is positive 3. So let's think of some numbers that multiply to make a negative 70. One of them will have to be negative. 7 times 10 comes to mind immediately. If I was to make the 7 the negative 1, those would still multiply to make negative 70, and they actually would add to make a positive 3. So we are ready to go. Step 5, divide both numbers by a. Well, our a is now positive 1. I don't have to do that because it's not going to change anything. Step 6, set up your binomials. Don't forget about the negative 1 in front. So we've got here, oh dear. Here are two numbers, negative 7 and positive 10. So I've got x minus 7 and x plus 10. I don't have any fractions, so I don't have to do step 7. We just need to do step 8, which is to check. So let's go ahead and check. Again, oh, and I forgot. Look, I put x again instead of t. Let me fix that before I forget. I can't believe I keep messing that up. T. All right, there we go. I got it right this time. I caught it a little sooner. So t minus 7, and then t plus 10. I always put a tail on my t's so they don't look like pluses. All right, first thing we're going to do is double distribute, and then when we're done with that, we'll distribute that negative 1. So we're going to keep the negative 1 for right now. All right, t times t is t squared. T times 10 is plus 10t. Negative 7 times t is negative 7t. And negative 7 times 10 is negative 7d. Combine the two middle terms, positive 10t and negative 7t, combine to make positive 3t. Bring down everything else. And remember, there's that negative 1 in front. So now is the time when we distribute that negative 1 into our parentheses. And all that does is change the sign of everything. Negative 1 times t squared is negative t squared. Negative 1 times 3t is negative 3t. And negative 1 times negative 70 is positive 70. So this is what we get. And that does match what I have here after we rearrange the order. So that means we did factor correctly. And this is the last example. Step 1, factor out the GCF. No GCF. Remember, there's a 1 in front of d squared. They don't have any factors in common other than 1. Step 2, identify your a, your b, and your c. Our a is 1. Our b is positive 3. Our c is positive 3. Step 3, set up your x. Put a times c in the top, b in the bottom. A times c is going to be 1 times 3, which is 3. B is also 3. So now I got to think of numbers that multiply to make 3 and that add to make 3. The only numbers I know that multiply to make 3 are 1 and 3. But those add to make 4. Well, what if I made them both negative? That would still multiply to make positive 3, but those would add up to a negative 4. So there's no other factors of 3, which means that this example is not factorable. So if you're spinning your wheels and you're trying to find numbers for here and here and nothing is working, that could mean that your trinomial is not factorable, and that will happen from time to time. If this is the case, and we'll actually learn about this the next week, I would want to use the quadratic formula. So that's when we would want to use the quadratic formula. Quadratic formula can always be used, regardless of if it's factorable or not. But if you can factor first, sometimes that makes it a little bit easier. Right now, you don't know the connection between what we're doing, but next week we're going to put it kind of all together. So not factorable is a possibility. All right, there's a lot of notes. Hopefully you have some good practice. Go do some of the practices now and let me know if you have any questions. Good luck.